When dividing fractions, I want to be thinking about how many 1/2s fit into 7/8. Well, 2 of them don't fit in, but it's close, so it's somewhere between 1 and 2, because it's certainly more than 1. If I think about it pictorially, I've got a picture here with eighths. 7/8 would be all but one of them. How many halves fit in? Well, here's a half right here. 1 fit in. What part of a half fit in? Well, this is 3/4 of a half. So the answer to this is 1 3/4. We're going to be doing this problem in another way. We can also see this just by dividing across. 7/8 divided by 1/2 is equal to 7 divided by 1 is 7. 8 divided by 2 is 4. That's equal to 1 3/4. This is a very simple way of doing the problem if my denominators and numerators can divide easily. If not, I end up with something more complicated. I can also do this problem by using some arrows and thinking about this fraction problem as not a division problem, but as a multiplication problem. The first fraction stays 7/8. I then change the division into multiplication, and I can use what's called the reciprocal by flipping over the 1/2 to 2/1. When I multiply that across, I get 14/8, which simplifies to 7/4. Notice again, it's the problem I started with, and that's equal to 1 3/4. This will always work because when I'm dividing by a half, it's the same as multiplying by 2. If I say how many halves go into something, well, for every 1, there's 2 of them. So it's the same as saying if I said 10 divided by a half, I'm really thinking 10 times 2. There are 10 groups of 2 because a half goes in twice. So we can always multiply by the reciprocal.